All right, since you have those here, let's have a look at assignment 54. With question 1. Okay, for this kind of question, usually we'll put everything on the left-hand side and rewrite the whole expression using the common denominator, right? Okay, so the original problem is equivalent to minus 5x plus 8 over 4x minus 1 minus 9, right? Less than 0. And common denominator is 4x minus 1. So you can rewrite the whole expression on the left-hand side using the common denominator. Minus 9 times 4x minus 1, 4x minus 1, less than 0, which is equivalent to 5x plus 8 minus 9 times 4x is 36x. Minus 9 times minus 1 is plus 9, right? Over the common denominator, which is 4x minus 1. And this ratio should be less than 0. Okay, and numerator can be simplified to minus 41x plus 17 over 4x minus 1 less than 0. And here we have a ratio that is less than 0, which is equivalent to the signs in front of the numerator and denominator should be different, right? So this is equivalent to first case, we can either have a negative numerator and a positive denominator, or we can have a positive numerator and at the same time the denominator should be negative, right? Okay, now let's solve the two separate questions here. First question is equivalent to x greater than 17 over 41, and x should be also greater than 1 over 4, right? Okay, second sub question is equivalent to, first of all, x should be less than 17 over 41, right? And x should also be less than 1 over 4. Okay, now we need to compare which number is larger. So 17 over 41 is about 0.4 something, right? And 1 over 4 is exactly 0.25. So which one is larger? Of course, 17 over 41 is larger, right? And this is 1 over 4. Okay, so first question, the solution to the first question is x should be greater than the greater number, right? Which is x should be greater than 17 over 41. Second sub question, if x should be less than both of the two numbers, the overlapped area is, of course, x should be less than the smaller number, which is 1 over 4, right? Okay, so the final solution is x is either greater than 17 over 41 or x is smaller than 1 over 4. Okay, have a look at this. Do you have any questions? No? All right, let's see question 2. Okay, question 2, again, we can't just multiply 6 plus 5 to both sides because we don't know the sign in front of this expression, right? So we can only put everything to the left-hand side and rewrite the whole expression using the common denominator. Okay, this is equivalent to 3x minus 7 over 6x plus 5 plus 6 times 6x plus 5 over 6x plus 5 greater than or equal to 0, right? Which is further equivalent to 3x minus 7 plus 6 times 6x is 36x. 6 times 5 equals 30. Over the common denominator, which is 6x plus 5, should be greater than or equal to 0, right? Okay, now let's simplify the numerator. 3x plus 36x is 39x. Minus 7 plus 30 is 23. Over 6x plus 5 should be greater than or equal to 0, right? And this is further equivalent to, first of all, the expression on the left-hand side can be exactly 0, right? Okay. Or the ratio between 39x plus 23 and 6x plus 5 can also be greater than 0, right? Okay, so the equation is equivalent to, if we have a ratio that is 0, this is equivalent to the numerator must be 0, and at the same time, the denominator cannot be 0. Okay, for the inequality, if we have a ratio that is greater than 0, this is equivalent to the signs in front of the numerator and denominator should be the same. So we can either have both of the denominator and numerator greater than 0. That means both of them are positive, or both of them are negative, right? Okay, so the original problem is decomposed to these 3 sub-questions. Okay, first, you can easily solve that x equals minus 23 over 39. And at the same time, x cannot be minus 5 over 6. Okay, second inequality is equivalent to, first of all, x should be larger than minus 23 over 39. Second, x must be greater than 5 over 6. Or we can also have x less than minus 23 over 39. And at the same time, x should be less than minus 5 over 6. And now it's time to compare these two numbers, which one is larger, right? So minus 23 over 39 is about minus 0.59 something. And minus 5 over 6 is about minus 0.83. So which number is larger? Of course, minus 23 over 39 is larger, right? So suppose here is minus 23 over 39. Then minus 5 over 6 must be to the left of minus 23 over 39, right? All right, so the solution is, first, x can be exactly 23 over 39, or x should be larger than the two numbers. the overlapped area is x must be larger than the larger number, which is minus 23 over 39, right? Okay, or x can be smaller than the two numbers, which is equivalent to x must be smaller than the smaller number, which is minus 5 over 6, right? Okay, so considering all of these solutions, the final solution is x is either equal to or greater than minus 23 over 39, or x can also be smaller than minus 5 over 6. This is our final solution. Okay, please have a look at this. Any questions? Let me know. No questions? All right, let's see. Question 3. What is a possible range of M such that the system of inequalities has no solutions for X? Okay, for a question like this, first of all, we can try to solve the system of the inequalities in terms of X, right? Okay, so let's call this star. Okay, so system star is equivalent to, okay, first inequality, we can just divide both sides using -2, right? Because -2 is a negative number. So when you divide both sides using a negative number, you need to change the direction of the inequality sign, right? So this is equivalent to x is less than or equal to 3m plus 7 over -2. And the second inequality, we can just divide both sides using 4 because 4 is positive. We don't need to change the direction of the inequality symbol. So second inequality is equivalent to x is greater than or equal to 5m minus 8 over 4, right? Okay, so now the solution is x should be smaller than a number, and as well as x is greater than a number, right? Let's call the first number is k1 and second number is k2. The question is, what should be the relative position of k1 and k2 in such that there is no solution for x? Okay, so suppose this is our k1. Question is, where should be k2? To the left of k1 or right of k1? Such that there is no solution for x. Okay, please tell me, where should be k2? Left or right? Okay, Emily just gave me an answer. How about Dora? Can you tell me where should be k2? To the right of k1, right? Okay, so both of you got this correct. So our k2 should be here, such that x has no solution. Why? Because the system says x should be less than or equal to k1. And at the same time, x should be greater than or equal to k2, right? So the solution is overlapped area of these two. So as soon as K1 is to the left of K2, there's no overlapped area, which means there is no solution for X. Okay, question is, can K1 be exactly K2? Okay, if K1 is exactly equal to K2, what will happen? The solution now is X should be smaller than or equal to K1, and X should also be greater than or equal to K2, right? In this case, the solution is exactly X being K1 or K2. So K1 cannot be exactly as K2, right? Okay, so according to our analysis, if K1 is smaller than K2, then no solution for X. Okay, let's call this. All right, so K1 smaller than K2 is equivalent to, which is K1. K1 is 3m plus 7, right? Sorry, over minus 2. So K2 is 5m minus 8 over 4. So that means if the inequality here satisfies, there's no solution for X. This is equivalent to, okay, we need to solve this inequality, right? You can just multiply both sides using a positive 4. If you multiply both sides using a positive 4, we don't change the direction of the inequality symbol. So left-hand side becomes minus 2 times 3m plus 7. Right-hand side becomes 5m minus 8, right? This is equivalent to minus 6m minus 14, less than 5m minus 8, right? Which is further equivalent to 11m greater than minus 6, which means m should be larger than minus 6 over 11, right? Okay, so the conclusion is if m is greater than minus 6 over 11, there is no solution for X. Okay, did you get it? Any questions? Okay, so question 1, 2, 3 are simple questions in this chapter. So next time, I think you did pretty well. So next time we probably don't practice these questions anymore. We'll move to the next part. Okay, question 4. In the 2D Cartesian plane, shade the region which is solution to the inequalities 8x minus 4y less than minus 32. Okay, so how do you shade the corresponding area? First of all, we need to find the boundary line, right? Okay, let's consider this inequality here. 8x minus 4y less than minus 32. Okay, first of all, we need to separate x and y, right? So this is equivalent to 4y greater than 8x plus 32, right? And then we can divide both sides using a 4. 4 is positive, so we don't change the direction of the inequality symbol. And this is equivalent to y is greater than 2x plus 8, right? And now we have successfully separated x and y. The corresponding line, let's call this L1, is y equals 2x plus 8, right? Now you need to find this line in the Cartesian plane. Okay, the best way to draw this line is to find its x and y intercept first, right? So let's say when x is 0, when x is 0, y equals 2x plus 8. Of course, y is 8, right? That means this line passes through point 0.8. 0.8, suppose 8 is here. Okay, next, let's find its x-intercept. This means when y is 0, x is -4, right? So this line also passes through -4, 0. Okay, and now we can find this line by connecting these 2 points. Okay, so this is the boundary line. But remember that this inequality is strictly smaller than, so we need to use the dotted line instead of the solid line. Solid line means greater than or equal to, or less than or equal to, right? Dot line means strictly less than or strictly greater than. All right, this is a boundary line. So where is the shaded region? Where is the region that is corresponding to the inequalities? Inequality is y is greater than, right? Greater than means the region must be above this line, right? So this is our shaded region. You can just shade it like this. This is our region. Okay. Or you can use a arrow like this. Shaded region is to the is above this line. Okay, any questions? No? All right, let's see question 5. Write the expression inequality of the area below the given line as shown in the following graph. Okay, so in this question, usually we'll find the equation of this line first, right? Okay, so the given line is, okay, so we know the x-intercept is -4, and y-intercept is 0, 2, right? So we can write this line using a 2-intercept form, right? Say 2-intercept form is x over the x coordinate of the x-intercept, which is -4, right? Plus y over the y coordinate of the y-intercept, which is 2, equals 1, right? This is a 2-intercept form of the equation of this given line. Okay, now we need to separate x and y. So we can multiply both sides using a 4. This means -x plus 2y equals 4, right? And this is further equivalent to 2y equals x plus 4. And this is equivalent to y equals 1/2 of x plus 2, right? So this is the equation of the given line. And note that the shaded area is below, just below this line. And also the line is a solid line. So the area is denoted by inequality because the area is below this line. So we need to change the equality symbol to inequality symbol, which is y is smaller than 1/2 of x plus 2. But remember that the line is a solid line. Solid line means the area contains this line itself. So we need to also put an equality symbol, right? Okay. Any questions? No? All right, let's move to the next question. Question 6, graph the region of points that satisfy both inequalities. Okay, two given inequalities, and it asks us to find the overlapped area. Okay, so let's call this inequality 1 and inequality 2. So first of all, we need to find the corresponding boundary line, right? Inequality 1 is equivalent to, okay, first of all, in order to find that line, we need to separate x and y. This is equivalent to y is greater than minus 2x plus 6, right? And corresponding line, let's call it L1, is y equals minus 2x plus 6, right? And then we can find this line in the 2D Cartesian plane. Again, in order to find this line, it's better to find its x and y intercept. So when x is 0, you need to check when x is 0, what is y? When x is 0, y is 6, right? And also know that when y is 0, x equals 3. Okay, so now let's draw this line in the Cartesian plane. Okay, y-axis and x-axis. First line passes through point 0, 6. Okay, suppose 6 is here, and also passes through 3, 6. 6 is there, and 3 should be halfway. It's about here, right? And note that the equal symbol is strictly greater than. So we need to use dot line to indicate strictly greater than. Okay, this is our first boundary line. First boundary line. L1. And inequality says y should be greater than this line, right? Greater than this line, greater than means the region should be above this line, right? So this is our corresponding region, which is above this line, right? Okay, now let's consider the second line. Okay, let's use another color. How about green? Okay, second inequality is equivalent to 4y smaller than or equal to 3x plus 12, which is equivalent to y smaller than or equal to 3 over 4x plus 3, right? Okay, so the corresponding line L2 is y equals 3 over 4x plus 3. Now let's check the x and y intercept. When x is 0, y equals 3, right? And when y is 0, x equals minus 4. So this line passes through 2 points, which are 0, 3. 0, 3 about here. And second point is -4, 0. -4, 0 is about here. And note that the inequality says y should be smaller than or equal to. This means the line should be a solid line, right? You use a solid line to indicate the second line, L2. Okay, so this line should look like this. This is our L2. And the region is above this line or below this line. Let's check the inequality. Inequality says y should be smaller than or equal to. This means the region should be below this line, right? Okay. And let's go back to the original question. Original question says graph the region of the points that satisfy both of the two inequalities. This means we need to find the overlapped area that is satisfying both of the inequalities. So according to the graph, apparently the overlapped area is here, right? This is a boundary line. There is another boundary line. And this should be the area we are looking for, right? Okay, please have a look at this question. You have any question you want to ask? No? Okay, let's see question 7. Graph the region of points that satisfy all of the following inequalities. So now we have 4 inequalities, right? The methods are actually similar to the one we used in previous question. So let's call this inequalities number 1, 2, 3, and 4 respectively. First of all, we need to find the corresponding boundary lines of these inequalities, right? Okay, so first of all, first inequality is equivalent to, remember we need to separate x and y in order to find the corresponding line and then the region, right? So first inequality is equivalent to y should be greater than or equal to, should be less than or equal to, because we want to move y to the other side, right? X plus 4. And corresponding line, let's call this L1, is y equals x plus 4, right? So when x is 0, y equals 4. And when y equals 0, x equals -4, right? So that means we can draw the line on the 2D Cartesian plane now. So apparently this line passes through 2 points. First point is 0, 4. 0, 4. Okay, suppose 0, 4, 4 is here. And second point is -4, 0. Let's extend the axis a little bit. -4 should be about here. Note that the inequality says y should be equal to or less than. So we need to use a solid line, right? Okay, this is our boundary line L1. L1. And according to the inequality, y should be less than or equal to x plus 4. This means the region should be under this line and including this line, right? So this is our first region. Okay, now let's look at the second. Let's use another color, red. Second inequality is equivalent to y is less than -2x plus 2, right? And then we can find our second boundary line L2, which is y equals -2x plus 2, right? Also, we need to find its x and y-intercept in order to draw this line easily. When x is 0, y is 2. And when y is 0, x is 1, right? So it passes through 2 points. 1 point is 0, 2. 0, 2 is about here. And second point is 1, 0. 1, 0 is here. Okay, so 1, 0, and 0, 2. And again, the inequality says y should be less than or equal to. So again, we need to use a solid line, right? Okay, so this is our second boundary line, L2. Inequality says y should be less than. Less than means the region should be under this line. So this is the corresponding region. Okay. All right. The third inequality says x should be greater than or equal to -1. So the corresponding boundary line L3 is x should be equal to -1, right? X equals -1 is a vertical line that is parallel to y-axis and passes through -1, 0. So third line should look like this. This is -1. And also because the inequality says x should be greater than or equal to. This means, again, we need to use a solid line. Okay, so the third line probably looks like this, right? The only thing you need to check is this line passes through the intersection between L1 and L2, right? So before you draw this line, it's better to check the intersection between L1 and L2, right? Because L3 could look like this, or this, or this. You need to check the intersection between L1 and L2 is to the left or to the right, or is on line 3, right? Okay, so let's call this point P. Okay, so we need to check point P to the left or right, or exactly on line L3. So in order to check that, we need to find the coordinates of P, right? P is the intersection between L1 and L2. So in order to find its coordinates, we need to combine the equations of line 1 and line 2, which is equivalent to the line 1 is y equals x plus 4. Line 2 is y equals minus 2x plus 2. This will give us an equation, x plus 2 equals minus 2x plus 2, which can be solved to 3x equals minus 2. And this gives us x equals minus 2 over 3, right? So the x coordinates of point P is minus 2 over 3. This means a point P must be to the right of line 3, right? Because line 3 is x equals minus 1. Minus 2 over 3 is, of course, greater than minus 1, right? So to this point, we can safely draw line 3 like this, right? Okay, so this is our line 3. And according to the inequality, it says x must be greater than or equal to minus 1. So region 3 must be to the right of line 3. This is our region 3, right? Okay, so there is another inequality, which is y should be greater than or equal to 1, right? So the corresponding boundary line, let's call this L4, is y equals 1, right? Okay, so y equals 1. Also, in order to draw line 4 could look like this, this, or this. We need to check if point P is above line 4 or below line 4 or exactly on line 4, right? So in the previous step, we also need to find the y coordinate of point P. So when x is minus 2 over 3, y is 10 over 3. This is the coordinate of P, right? So coordinate of P is minus 2 over 3, 10 over 3. Okay, let's put it here. Also, it's better to use another color. Let's say black. Okay, point P. Coordinate of point P is minus 2 over 3, 10 over 3. So 10 over 3 is about 3.3 something, right? Of course, it should be above line 4, right? Because line 4 is just y equals 1. 1 is here. Or line 4 should look like this. Okay, this is our line 4. Again, check the relative position of P to line 4. The y coordinate of P is 10 over 3. Of course, 10 over 3 is greater than 1. So P must be above line 4. Okay, so in this way, we can safely draw line 4 in this position. Okay. All right, so according to the fourth inequality, it says y should be greater than or equal to 1. So the region of this inequality is above line 4, right? Okay, so considering the 4 inequalities, the bounded region should look like this. So first of all, there is a boundary here, right? And another boundary line here. Must be below line 1, below line 2, to the right of line 3, and above line 4, right? So our bounded region should look like this. This is overlapped area. Okay, understand? Okay, if you are still not very clear, let's draw the 4 boundaries here. First of all, it must be below line 1, right? So there's a boundary line here. And second, it must be below line 2. And of course, it should also be to the right of line 3. And last, it should be to the it should be above line 4. So these are the 4 boundary lines, and the yellow shaded area is overlapped area we are looking for. Understand? Okay, please have a look at this. Any questions? No? All right, let's see question 8, which is a linear optimization problem. Find the maximum value of 3x plus 4y such that the following 3 inequalities are satisfied. Okay, according to the hint actually gives us a method to solve such a question. So first of all, we need to find the bounded area in the 2D Cartesian plane according to the given 4 inequalities, which is very similar to what we have done in question 7, right? Okay, so first of all, let's label the 4 inequalities here. Number 1, 2, 3, 4, respectively. Okay, so inequality number 1 is equivalent to, remember, in order to find the shaded area, we need to separate x and y and find the line in the slope-intercept form, right? So first inequality is equivalent to y is less than or equal to minus 2x plus 6, right? And the corresponding line L1 is, of course, y equals minus 2x plus 6. When x is 0, y is 6. And when y is 0, x is 3, right? Okay, so now we can draw the first line and its corresponding region on the 2D Cartesian plane. Okay, y-axis and x-axis. First line passes through 2 points. First point, 0, 6. Second point, 3, 0. So this is the first line, and it should be a solid line, right? Because inequality says less than or equal to. Okay, this is our line L1. And according to the inequality, y should be less than or equal to. Less than or equal to means the region should be below this line, right? So this is the first region. Okay. Inequality number 2 is equivalent to y is less than or equal to x plus 3, right? And of course, the corresponding line L2 is y equals x plus 3. And when x is 0, y is 3. And when y is 0, x, of course, equals -3, right? So second line passes through 2 points. The first point is 0, 3, which is about here. Next point is -3, 0, is around here. Okay, remember, when you draw the sketch, it's not necessarily to scale, as long as it ensures the relative positions of every element is correct. Okay, so second line should probably look like this, right? Let's label it using L2. Okay, inequality says y should be less than or equal to. Less than or equal to corresponding to the region below this line. So this is our second region, right? Okay, next, inequality number 3 is just x greater than or equal to 0. So the corresponding line L3 is x equals 0, right? X equals 0 is just the y-axis, right? So this is the y-axis is actually our line 3. And this time we don't need to check the relative positions between L3 and the intersection point here, because according to the 2 lines we have already drawn, the intersection point here must have a positive x coordinate, right? So this time we can just draw L3 on the y-axis. And the inequality says x should be greater than or equal to 3. So this means the third region is to the right of the y-axis. This is our third region. And the fourth inequality says y should be greater than or equal to 1. So corresponding line L4 is y equals 1, right? Okay, so now you need to check y equals 1. Where's 1, right? Y equals 1. 1 is about here, right? And technically, you need to check whether this intersection point is above this line or under this line. For this particular problem, it's very easy to see because we have already know that the red line passes through 0, 3, and the intersection point must have a y coordinate that is greater than 3, right? Greater than 3 means must be greater than 1. So we can just directly draw the fourth line like this. This is our fourth line. And according to the inequality, y should be greater than or equal to 1, right? So this means the fourth region should be above line 4. This is line 4. Okay, so now can you see where is the overlapped area? The overlapped area should be here. First of all, it must be under 2. Second, it must be to the right of the y-axis. Third, it must be above line 4, right? And last, it must be also below L1, which is a blue line. So basically, this is our shaded region. We only need to consider the target function in this bounded region and calculate different values at the different vertices, which means let's call them P1, P2, P3, and P4. So this region has 4 vertices, right? Next, we need to calculate the coordinates of P1, P2, P3, and P4. P1 is the intersection point between L1 and L2. In order to find its coordinates, we need to combine the equations of L1 and L2, which means y equals minus 2x plus 6 and y equals x plus 3, right? So you can easily solve that 3x equals 3, which means x equals 1, right? When x equals 1, when you put it back to the original system, y can be easily solved to 4, right? So the coordinates of P1 is just 1, 4. Okay, so using the same method, we can find coordinates of P2, P3, P4, right? Okay, how about P2? P2 is very easy because it is just the y-intercept, because it's just the y-intercept of the red line, which is 0, 3, right? Okay, similarly, P3 is also very easy to find. It's just the regional, it's just the y-intercept of L4, which is 0, 1. 0, 1, yes. Okay, so how about P4? P4 is here, right? P4 is the intersection point between L1 and L4, which is y equals minus 2x plus 6 and y equals 1. Of course, it's very easy to solve that. The intersection point has y coordinate being 1 and x coordinate being 5/2, right? Okay, so that means the coordinates of P4 is 5/2, 1, right? Okay, so we have the coordinates of P1, P2, P3, and P4 now. Now we only look at the value of the target function at these vertices and decide which one has a larger value. Okay, so we can draw a table like this. First column is different vertices. Second column is our target function, which is 3x plus 4y, right? Okay, P1 is 1, 4. P2 is 0, 3. P3 is 0, 0. And P4 is 5/2, 1, right? And at different vertices, target function is 3x plus 4y. So at P1, value is 3 times 1 plus 4 times 4, which is 3 plus 16, which is 19, right? At P2, target function is 3 times 0 plus 4 times 3 equals 0 plus 12 equals 12. We add P3, 0 times 0, 3 times 0 plus 4 times 0, which is 0. Sorry. The y coordinate is 1, not 0. So 3 times 0 plus 4 times 1, which is 0 plus 4 equals 4, right? We got P4. 3 times 5 over 2 plus 4 times 1, which is 15 over 2 plus 4, which is 11.4, right? Okay, so now can you see which one is the largest? Of course, 19 is the largest of the 4, right? So now we can make the conclusion. Therefore, when x is 1 and y is 4, the maximum of target function, which is 3x plus 4y, is 19, right? Okay. Let's have a look at this. Do you have any questions to ask? This is a final solution. Okay, any questions? No? All right. Let's have a look at the last question. Please be careful and pay attention to this question because neither of you has done this correctly. So question 9 is actually the same thing as question 8. The only difference is it is a real world problem. You need to convert an English statement into the mathematical model, which looks like this by yourself. Okay, so let's have a look how we can do this. Okay, let's read the questions together. Farmer Fred will plant corn and beans. Okay, so basically it tells you that this person can plant 2 types of crops, right? Fred has 120 acres he can plant. Each acre of corn requires 5 pounds of fertilizer, and each acre of beans requires 7 pounds of fertilizer. Meanwhile, each acre of corn requires 2 pounds of pesticide, while each acre of beans requires 4 pounds. Each acre of corn produces 100 worth of corn, while each acre of beans produces 120 worth of beans. So Fred has 660 pounds of fertilizer and 340 pounds of pesticide. What is the largest amount of revenue Fred can produce? So basically, it means there is a person, he can choose to plant corn or beans or a mix of both, right? And these crops can bring revenues. And there are some limitations because he has limited size of land and limited amount of fertilizers and limited amount of pesticide, right? He can't just plant corns or beans unlimited. Okay, so how about we make a table? So he can choose to plant corn or beans, right? So let's use the letter corn to denote corns and a letter B to denote beans. And for each crop, the crops will occupy some land, right? And for each type of crop, that crop requires fertilizer. As well as pesticide, right? And of course, each type of crops can bring some revenue. Okay, so suppose suppose Fred have planted C acres of corns. Okay, let's make it clear. C acres of corns and B acres of beans. So how many land will the corn occupy? According to the statement here, each acre of corn requires so suppose I have grown C acres of corn. So the land size the corn occupied should be C, right? And of course, if you plant B acres of beans, the land size the beans occupied should be B, right? And remember that the total size of the land is 120. That means the total land size, B plus C, cannot exceed 120. That means B plus C should be smaller than or equal to 120, right? And if he plants C acres of corn, we have already know that each acre of corn requires 5 pounds of fertilizer. So that means for C acres of corn, it requires 5 C pounds of fertilizer, right? And for each acre of beans require 7 pounds of fertilizer. That means for B acres of beans, it requires 7B total pounds of fertilizers, right? So the total fertilizers needed for the two types of crops is 5C plus 7B. And this amount cannot exceed the total amount of fertilizers Fred has, which is 660, right? So 5C plus 7B should be less than or equal to 660. Okay, third, pesticide. For each acre of corn, it requires 2 pounds of pesticide. So for C acres of corn, we need 2C pounds of pesticide, right? So similarly, for B acres of beans, it requires 4B pounds of pesticides because the statement says each acre of beans requires 4 pounds. That means B acres of beans needs 4B total pounds of pesticide, right? So the total pesticide used should be 2C plus 4B. And this amount cannot exceed the maximum Fred has, which is 340, right? Can you follow me? Okay, so let's say this is a constraint of land. This is called constraint of fertilizer, right? Because we have limited amount of fertilizers. And this is constraint of pesticide. Also, we have limited amount of pesticide. Okay, can you follow me? All right. So how about revenue? Each acre of corn can bring 100 revenue, right? So C acres of corn can bring us 100 multiplied by C dollars, right? And each acre of corn produces $120. So B acres of beans, sorry, beans, not corns. Each acre of beans produces 120. So we have B acres. That means the total revenue from beans would be 120 times B dollars, right? So the total revenue is 100C plus 120B, right? This is our total revenue. So target is to, this is our target. We need to maximize the revenue, right? Okay, hold on a minute, sorry about that. Okay, let's continue. So the target is to maximize our revenue. That is to maximize this expression, right? So let's rewrite the question. Okay, so the original question can be rewritten as we need to maximize target function 100C plus 120B. Given that, okay, first of all, B plus C must be smaller than or equal to 120. Second, 5C plus 7B must be smaller than or equal to 663, right? Third, 2C plus 4B must be smaller than or equal to 340, right? And remember that B stands for B acres and C stands for C acres. These two quantities must not be negative, right? So of course, B must be non-negative and C is also non-negative. So this is actually the mathematical form of this problem, right? And can you have a look at this? Is this similar to the problem stated in question 8? Question 8 simply states that you need to find the maximum of this one, given the constraints like this, right? And in question 9, our target is to maximize this expression, given that 5 constraints here, right? So the method is quite similar. So now let's try to solve these problems. Okay, can you follow me? Okay, now it becomes a pure optimization problem. Okay, how about Dora? Can you follow me? Okay, so what is the method to solve this? First of all, we label these constraints to 1, 2, 3, 4, 5, right? We find these boundary lines and the boundary areas. Okay, first, inequality is equivalent to, let's separate B and C, right? Actually, C can be regarded as or Y, B is X, or you can change the order. It does not matter, right? So let's say first inequality is equivalent to C is less than or equivalent to, C is less than or equal to minus B plus 120, right? And of course, the corresponding line 1 is C equals minus B plus 120. And we know that when B is 0, C is 120. And when C is 0, B is 120, right? Okay, so now let's draw the first line on the 2D Cartesian plane. Okay, let's draw this larger. Y-axis and x-axis. Okay, so first line passes to 2 points. First point is 0, 20, 0, 120, and second point is 120, 0. Sorry, it's not x and y. Here, we use the letters C and B, right? So C is our vertical axis and B is horizontal axis. Okay. All right, suppose 120 is here and 120 is here. Again, not necessarily to scale as long as you ensure the right positions of each element is correct. Okay, so this is our line 1. Line 1. And according to the inequality, C is less than or equal to minus B plus 120. That means the region is under this line, right? This is region 1. Okay, so first line has drawn, and second, let's consider the second inequality, which is equivalent to 5C smaller than or equal to minus 7B plus 660, which is equivalent to C is less than or equal to minus 7 over 5B plus 132, right? And corresponding line 2 is C equals minus 7 over 5B plus 132. So when x coordinate C, x coordinate B is 0, C is 132, and one vertical coordinate C is 0, B is 660 over 7, right? Okay, so this means we can draw the second line on the graph now. It passes 2 points. First point 0, 1, 3, 2. 0, 1, 3, 2, suppose it's here. And next point is 660 over 7, 0. So 660 over 7 is about, because you need to check it's to the right or left of 120, right? So 660 divided by 7 is about 94 something. So it must be to the left. Of 120. So this is 660 over 7. Okay, so second line should look like this. Let's draw this a little higher. All right, second line. L2. Also, according to the inequality, C is less than or equal to -7 or 5b plus 1, 3, 2. That means the area is under this line as well. All right, now let's consider the third region. Okay, the third one. Third inequality is equivalent to 2c less than or equal to -4b plus 340, right? And this is equivalent to c is less than or equal to -2b plus 170. So the corresponding line 3 is c equals -2b plus 170, right? So when b is 0, c must be 170. And when b is 0, b must be 85, right? So this means the third line passes through 2 points. First point is 0, 170. So suppose 0, 170 is here. Second point is 85, 0. 85 is here, right? 85 is here. It's the smallest of these three numbers here, right? Because 660 over 7, we have already know that that's a market here. 660 over 7 is about 94 something, right? So 85 should be to the left of this number. Okay, the question is, if we connect these 2 points, the green line here is the green line here to the left of the intersection point. Let's call this P1. Question is that the green line is to the left of P1, or it passes through P1, or shall it to the right of P1? All of the situations are possible, right? Because when we draw all the lines, when we draw all the elements, it's not necessarily to scale, right? Do you understand? So you need to check if the green line is to the left of P1, or in other words, is P1 above the green line or below the green line or exactly on the green line. Suppose, okay, let's suppose the third line look like this. Okay, let's assume that P1 is above the green line. Okay, let's check if it is true or not. So you need to check P1. Okay, I'll write it here. Check if P1 is above or under or on line 3. Okay, in order to check this, first of all, we need to find the coordinate of P1. P1 happens to be the intersection between line L1 and line L2. So in order to find its coordinate, we need to combine the equations of L1 and L2, which means C equals minus B plus 120 and C equals minus 7 over 5B plus 132, right? And we need to solve these equations. This gives us minus B plus 120 equals minus 7 over 5B plus 132, right? And this gives us 2 over 5B equals 12, which means B equals 30. And if we put B equals 30 to the original, one of the original equations, we can easily solve that C is 90, right? Okay, so let's make a note. All right, so P1 here is 3090. Okay. And therefore, P1 is 3090. So how do we check if P1 is above, under, or on L3? We can put the x-axis into the equation of line L3, right? So put x equals 30 into L3, which is C equals minus 2B plus 170. This will give us C equals minus 2, sorry, not X, this should be B. Minus 2 times 30 plus 170, which is 110, right? So that means on line 3, when B is 30, C equals 110, which is above 90. So this means this line must be above the intersection point, right? You understand? So our assumption here does not hold, because in this graph, as you can see here, the line is under this intersection point P1. And of course, according to our calculation, we know that this line should above P1, right? So it should look like this. We need to ensure that this line is above P1. So now let's draw a sketch. So suppose this is 85. Okay, suppose this is 85. This line should above P1, right? So it should look like this. And all the way to its Y-intercept, which is 170, right? Okay, so sorry about that. It looks not very straight because this is only a sketch, not necessarily to scale, okay? As long as each element maintains its relative position is okay. So we have already checked that P1 is under the blue line. So this is our line 3. It should look like this, right? Can you follow me? Also, you need to ensure that the Y-intercept 170 is the largest of these three numbers, and 85 is the smallest of these three numbers here. Okay, can you follow me? All right. Okay, according to the third inequality, C should be less than or equal to. That means the region is also under this line, right? This is our third region. It should be also under this line, okay? So for the fourth and the fifth inequalities, these are the simple ones, right? Okay, fourth, line 4, line L4. Fourth inequality says X should be, B should be larger than or equal to 0. So the boundary line is simply B equals 0. And for the fourth line, for the fifth line, line 5, line L5 is simply C equals 0, right? So according to the fourth constraint, B equals 0 is simply the vertical axis. So let's draw this here. This is the fourth constraint, and B is greater than or equal to means the area must be to the right of this line, right? Okay, the fourth constraint says C is above or equal to 0. So C equals 0 looks like the horizontal axis, right? And this constraint says where C must be above this line. Okay, so this is the fifth region. So now can you see what is the overlapped area of the 5 constraints, 5 inequalities? Let's mark them. Okay, first of all, this is a boundary line, right? Must be to the right of the vertical axis. And it must be under the black line, L1, right? Okay, so goes all the way down here. And it also should be below the red line, which is L2, right? And also below the green line, which is here, right? So last, it also should be above the horizontal axis. So basically, this is our bounded area. We need to check the target value only at the vertices of this bounded area. So how many vertices are there? We already know that one of the vertices is P1. And there is another one called P2 here, right? Let's call this P2. This is P1, this is P2, and this is P3, P4, and P5, right? This is P3, P4, and P5. Do you understand? I'll be clear. Hello. Okay, so what's next? What is the next step? The next step is to calculate coordinates of P1, P2, P3, P4, and P5, right? Okay, let's calculate them one by one. So we have already calculated P1. So this time let's start from P2. P2 is the intersection point between the green line here, which is L3, and the red line, L2, right? So let's combine L2 and L3, which means C equals minus 7/5b plus 132, and C equals minus 2b plus 170, which gives us minus 7/5b plus 132 equals minus 2b plus 170, right? And further, we can have 3/5b equals 38, which means p equals 190/3, right? And if you put b equals 190/3 to one of the original equation, c should be minus 2 times 190/3 plus 180, which is minus 330/3 plus 510/3, which is 130/3, right? So that means the coordinates of P2 is 190/3 and 130/3. Understand? Both of you understand? Okay, so let's mark this on the graph. P2 here. Coordinates of P2 is 190/3 and 130/3. Okay. Next is P3. P3 happens to be the x-intercept of L3, so it's not very hard to find, right? So let's directly write, because it's x-intercept, the y-axis is 0, right? X-axis, we already know that is 85, right? Okay, so P3 is easy to find. 85, 0. So how about P4? P4 is a regional point. Of course, it's 0, 0, right? Okay, so the last point is P5. P5 happens to be the y-intercept of L1. So we know that this x coordinate is 0 and y coordinate is 120, right? Okay, so now we have the coordinates of P1 to P5, because these are the only vertices of the bounded region. So we only need to check the target function at these vertices only. So again, let's make a table. Vertices. Okay, let's see. P4 is 0. P5 is 0. 120. Okay, let's put all these vertices into the table. P1. Okay, first column, vertex. Second column is target function, which is target function is 100C plus 120B, right? So 120B plus 100C. Okay, first vertex P1, coordinates 3090. Okay, second P2, coordinates 190 over 3 and 130 over 3. Third P3, 85, 0. P4, 0, 0. P5, 0, 120. Okay, so according to the hint, we only need to check the target function as these vertices. One of them must achieve maximum and one of them must achieve minimum, right? So at P1, the target function is 120 times 30 plus 100 times 90, which is 3600 plus 9000, which is 12600. Okay, second vertex P2, 120 times 190 over 3 plus 100 times 130 over 3, which is 7600 times plus 13000 over 3, which is 35800 over 3. In order to conveniently compare the numbers, let's rewrite this using decimals. So 35800 divided by 3 is about 11933. 11933, right? Okay, third vertex is 120 times 85 plus 100 times 0, which is 102. 10200. And fourth vertex, simpler one, right? 120 times 0 plus 100 times 0, which is 0. And fifth, the last vertex is 100 times 0 plus 100 times 120, which is 12000, right? And now can you see which one is the largest? Of course, this number seems to be the largest, right? So now how can you make the conclusion? How can we make the conclusion? Therefore, the conclusion is when B is 30, C is 90, the maximum of 120B plus 100C is 12600, right? And back to the problem in the real world, which means what's the name? Fred, right? When Fred plants. So what is B here? B is a total acre of beans, right? Plants 30 acres of beans. And what is C here? C stands for, what's the name of the crop? corn, right? So 30 acres of beans and 90 acres of corns. He can get the maximum profit of $1,2,600. Okay, this is our final conclusion. All right, any questions? Okay, please have a look at this. If you still feel confused, I'll upload this to Google Classroom and you can check my notes there. Okay, so our next assignment problems will be ready probably later today or tomorrow or the day after tomorrow. I'll let your parents know. Okay, so in our next assignment, we'll focus on problems like question 7, 8, and 9, especially the real world word problems. Okay, you need to able to convert the English statements into the mathematical statements by yourself, and then try to solve the mathematical problem by yourself. Okay, if you still don't know how to do that, just see the example here in question 8 and 9. All right. Okay. Any questions?